Yes, as a recording is also started. Now, the point is that today what we are going to talk about maybe I don't know. It depends upon our understanding, interest, and uh, complexity of the topic, as well as whatever we all during this whole time period understood about about deep learning. All those things are going to play a crucial role for our today's lecture. So, what we are going to talk about today is something very interesting. By the way, today's session is going to be again a type of extempore session in which we are going to talk about. So, I can write like NLP. So, if I say NLP, it's like natural language processing. And within that natural language processing, there are too many things that can be done. There are so many different types of questions that one can ask in the domain of natural language processing. And it may be like missing word prediction, next sentence prediction, subjective summarization, abstractive summarization of text generation, maybe image to text, text to image, and not restrictive to that. There are so many other things like name entity recognition, uh, part of speech recognition, and I mean these are few. In fact, there are so many others. Those who used to work on NLP, they are interested in NLP, maybe having better idea than me. But if I say that NLP going towards transformers, so it's completely true. I can bet maybe loosely, but I can say that whatever the NLP stuff that you can think of that can be one or the other way solved using transformer architecture. And transformer itself is actually a network in which we have an encoder unit. Then we have another unit that is called as a decoder unit. So some input will come here, will go in, we will get some output embedding. They are being fed or along with, you know, uh, uh, it depends on how you are going to give that embedding to the decoder. But once that decoding has been given to the decoder, so that is, input one, or not input. Let me write it like that is the input and the type of output you are actually predicting. So you start with the SOS or maybe some start token, and one by one you are going to get your outputs like O1, O2, O3, and so on. Even here also you are having inputs like I1, I2, and so on, maybe IK. And maybe here you will get a latent representation of input 1, latent representation of input 2, latent representation of input 3, and so on. So if I show it that all these things will be taken going inside our encoder, you will get a latent representation that can actually be shown to the decoder along with the type of output that you are looking for. So output first will give you SOS, and depending upon that start, it will say that decoder now you can start. So decoder will give you first in output, and that output is being fed to the input again as an input to the decoder, so as to get you then O2. So the flow of such network is that I1, I2, I3, I4, and all these things at once go in. And once you have got these things, you are going to get, a bunch of outputs. So these are the input related to representations, and these representations are being shown to this decoder. And decoder first is going to give you output number 1, which will be fed again to the decoder to give you the output number 2, which will be fed back, and you will get output number 3, then output number 4, then output number 5, and so on. So in this way, if you wanted to have input 1, input 2, input 3, and so on, maybe k different inputs, and wanted them to convert it into output 1, output 2, output 3, maybe L different outputs, then this is the way. And these type of networks, so the point is that previously along these NLP tasks, they were actually being predominantly being governed by deep learning architecture that we already have read, that is recurrent neural networks. And within this neural network, we have another term that's called as LSTM. So assume that this is your LSTM model that got unrolled in time, and here I1 is being given, then I2 will be given, then I3 will be given, maybe at last IK will be given. Whatever the latent or the hidden representation that you have got being given to the next LSTM layer, that's again, that will be given over here. And now you will get output number 1, that is output number 2, and so on, output number 3, output number 4, and output number L. So here you can see that we are actually having two set of LSTM layer networks, and both are actually trying to give you output 1, output 2, 3, 4, 5, and so on. So I1, I2, I3, these inputs go in. Then you have got a hidden representation, and this hidden representation is being shown to LSTM, the next layer LSTM, which is going to give you O1, then O2, then O3, then O4, and O5. How these type of, so this type of networks are also being called as many to many, because you are showing many inputs and many outputs are actually you are going to get. So this is being done in the case of RNN, and this specific problem is called a sequence to sequence modeling. And in sequence to sequence modeling, there are too many applications of the sequence to sequence modeling, and one most important such application is that which is language to language. So here you show Hindi, and later you generate English, or vice versa, English to German, German to France, and whatever. So these type of models we already have seen, but there are certain